Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 13 of the November LeetCode challenge and we have a medium level question in front of us. But let me tell you this very frankly at the starting itself, this is going to be slightly on the higher side because the way they have defined the time complexity of it, okay. If you see here, it is up the range 10 power 5 and once you see the question, you get to know that you cannot solve this question using an square approach, okay. So this question is on the medium level, but if you are not getting the approach they are trying you to follow, then this will be on the harder side, okay, because the solution won't be accepted. So let us see the question what it is. Given a zero indexed integer array nums, okay, uh, of size n and two integers lower and upper, return the number of fair pairs. Okay, what is a fair pair? Basically, a fair pair. Okay, I comma j is a fair if, see, remember I and j are indexes. Okay, they are not the values. Okay, they are just the indexes. Okay, I and j forms a fair pair if, okay, I is less than j. That is the first thing, and the sum of nums of I and nums of j is, in the range of lower to upper. Okay, both inclusive. Okay, it is greater than equal to upper and lower than equal to, sorry, greater than equal to lower and less than equal to upper. Okay, that is what they're trying to say. You can just see, read the question once again. So this question is very small, but see, there are many things happening here. Okay, first of all, you will think that I should not. Okay, if you're seeing this for the first time, okay, let me tell you this. The first idea that you will get is that you should avoid sorting. Okay, this is the idea that you will get. Why? Because see, if you sort, what will happen? You will be missing out on the indexes. Okay, because see, here the indexes are also important, right? So you will be missing out on the indexes. So one thing that I want to make is very clear is that indexes are not important here. For example, if you see here, let us say this particular 7 is present in the index 0, 3. Okay, it is present in the index 3. Considering the zero indexing, it is present in the index 3. So what will happen after sorting? This will lose its index. It will be in some other index. But the idea here is indexes are not important here. Why? See here. Let us say num size. Okay. Let us say I is less than j. So still nums. See, irrespective of what is I and what is j. Okay. Sums of I plus, so the nums of I plus nums of j will remain the same. Okay. Whether I is less than j or j less than doesn't matter, right? See, they have not specified that, right? See, they have just mentioned one of them should be lower than the other. Okay. What is I? What is j? It's not mentioned, right? It is nowhere mentioned what is I, what is j, right? They are just trying to tell I should be less than j. Okay, out of the two pair, see, for example, one of them should be low. That the basic idea here is that I comma j and j comma I both cannot be there in the answer. That is what they are trying to say. If you see here, all basically, see, this particular index should be less than this index. Okay, this index should be less than this, and like that. Okay, you cannot, if 0 comma 3 is there, then you cannot have 3 comma 0. That is the only idea. So that is what I'm trying to say is this particular index is not important as long as, okay, you are not taking the number with itself. Okay, that is I comma I is not possible. Okay, I and the index itself is not possible. Okay, that is one thing. Okay, other than that, you can then take the numbers and anywhere. The idea here is you can sort this array basically. Okay, even if you lose the index, that is not going to cause a problem because indexes are not important here. Okay, the only thing is you should take different indexes. Okay, you should not take the index with itself. Okay, that is the only idea. For example, let us say in this case, we see 0 and 3 forms of pair. Okay, 0 and 3 forms of pair, you should not take 3 and 0. Okay? If you ensure this, then you are good to ignore the indexes. Okay, that is the only thing that I want to tell you in the starting. That is fine. Now the next thing is what you can do. See, there are multiple things you can do. You can sort this out. Okay, you can sort this out and you can use two for loops. Okay, one for loop will go for each element of this. The second for loop will travel all the remaining elements what it's right. Okay, it will try to see the sum, whether the sum is in this range or not, and then it will be adding on the answer. You can try that, but let me tell you that particular solution will not be able to clear all the test cases. You will get time limit exceeded error. Okay, so that is the reason why if you see the time column of it will be, more or less it will be in the O of n square side, right? So that is not acceptable here. As simple as that. So that is the reason why we have to try approach which is, the most optimal in terms of the time complexity. Okay, that is the reason why I will be showing you the two pointer approach here. Okay, in my solution. See, there are multiple ways to do this. This question seems very simple in the starting, but let me tell you, it is not going to happen because your answer won't be accepted. There are multiple ways to solve it, but in this particular platform, your answer is not getting accepted with those approaches. Okay, I tried already multiple approaches, but the answer was not getting accepted. Okay, so that was the issue. So they are expecting only two approaches, and if your answer is in the time object of those approaches, only then it will get accepted. Okay, what are they? They are the binary search and the two-pointer approach. Okay, in this solution, I will be showing you the two-pointer approach in both Python and the Java. Okay, so let us quickly begin what I'm doing. So yeah, before I begin, so what I want to explain is that, see, the whole idea. Okay, so see, if you see here, this particular function is there and I'm returning a part. I'm using this function to find the answer. Okay, so what this function does, the whole answer depends on that. Okay, what it will do, see, first of all, I will be sorting. that is whatever nums is given to me, I will be sorting it. Okay, first thing. Next, what this function does? This function basically finds the number of pairs. Okay, this returns basically the count of number of pairs. Okay, having some less than the value. Okay, for example, I am passing a value here, right? So what it will do? It will return the that is indexes, that is number of pairs, okay, whose sum is less than this particular value. Okay, I will quickly run this and show you how it works. Okay, so we will do the tracing for the first example. Okay, so see here, this is going to be the two-pointer approach. Let us see how it works, right? So yeah, if you see here, the value that I passed is 7, okay, in the first place. Okay, why 7? If you see here, the upper is 6, so I am passing a value 7. Why I'm doing that, you will get to know that. But first, we are just trying to understand how the two-point approach works. Okay, so just understand, like, this value is given to you, and we are just doing the tracing. Okay, this tracing is for you to understand how it works. Okay, we'll come to the actual logic of why this we are passing this value. Okay, but let us understand this first. So what this function will do? See what output you are currently seeing. It is the output of how we are finding the number of pairs. Okay, which are less than a particular value. Okay, what is that value? In this case, it is 7. Okay, so we are currently finding out number of pairs whose value is less than 7. Okay, so let's see how it works. First, what we will do? Okay, initially you will see that we are taking the whole array as it is. Okay, remember this array first of all sorted. Okay, because if you see here, it is different. After sorting, it looks like this. Okay, next we are going to do the two-point approach to find number of pairs. Okay, which are less than a current value. Remember, less than. I'm not talking about equal to, only less than. Okay, so first I will do, this is the whole array I'm taking as it is. Okay, then the answer here is 0 initially. Okay, initially it is 0. What I'm doing, I will just take the last element of this and the first element of that is here, first and last elements. Okay, I will add them. Okay, 0 plus 7 is 7. Whether 7 is less than the value? No, 7 is not less than the value. That means I need to move the point in such a way that I start getting a lower value. So what I will do, I will move, that is I will remove the last element, okay, from my window. So what is my window? This will be my window now. Okay, so here I maintain this window. Okay, this is a new window. Now what I will do, I will again add the same thing, the zeroth element and the last element. Okay, from window. What is 0 plus 5? It is 5. Whether 5 is less than 7? Yes, 5 is less than 7. Okay, so the idea here is, my first element is, it can form pair with all the remaining elements, including the last element. Are you getting my what I'm trying to say? This first element 0 can form a pair with any of these elements. So how many pairs can be formed? 4 pairs can be formed. Okay, that is why this particular 4 is coming here. Why? See, 0 can form a pair with 1, 0 can form a pair with 4, 0 can form a pair with this particular 4, 0 can form a pair with this particular 5. Okay, so totally if you see, 0 can form a pair with each one of them. So totally 4 pairs can be formed. Okay, that's why the number 4 is coming, right? Now this particular pair, this particular window worked. What it worked? The initial value plus the highest value, that is the lowest value in this, plus the highest value in this particular window is less than equal to 7. So this worked. So what we will do now? We will try to move our window in such a way that we start getting a slightly above value. Okay. So what I will do? See, previously what I did. See, in this particular window, the sum of the lowest value and the highest value is equal to the value itself. That's why I don't want that. I want the window to be reduced in such a way that we start getting lower value. So what we did, we removed the last element. Okay, so we did like this. In this particular window, what happening? Yeah, the sum is less than the value, that is here the sum is 5, which is less than 7. So I still want a slightly above value. So what I should do, I will remove the first element out of the window now. Okay, so in this case, this particular element will be removed. So what is our window going to do? This is our window. Okay, this is going to be our window in the next iteration. So can you quickly tell me what is the sum of the first element and the last element now? It is 5 plus 1, which is 6. Is 6 less than 7? Yes, 6 is less than 7. So that means, again, same thing. So this particular first element, okay, here the first element is 1. This first element can form a pair with any of these 3 elements, okay. So I am again having 3 more pairs to my answer. So previously it was 4. I have 3 more pairs now. So 4 plus 3, which is 7 now, okay. So the answer, that the number of pairs that I found is 7, okay. Still, this again, this window is satisfying the condition that the smallest element plus the highest element should be less than equal to the value. Okay, 5 plus 1 is less than 7. Next, what I'm doing, because it satisfies a value, we are trying to get a higher value now. So I will remove again the first element. My window will be like this now. Okay, if you see in the next iteration, this is going to be my window. So can you tell me the sum of the smallest and the highest value here? 4 plus 5, which is 9. Okay, which is not less than 7. So this is not possible to form any pair out of it. Okay, so what we will do next, I will reduce the highest value of my window, that is, I will remove the last element of my window. So what is the window now? 4 and 4. So this iteration, we see it is 4 and 4. 4 plus 4, which is 8. Whether 8 is less than 7? No. So again, we cannot find anything. I will remove the last one again. So I will be left with only single element. Remember, with a single element, I cannot form a pair. So the loop will end there. So how many pairs we had? The value is 3. The idea here is, so the number of pairs, okay, whose sum is going to be less than 7 is going to be 7 itself. is going to be 7 itself. Okay. Similarly, I'm going to do with 3. Okay, I'm going to do with 3. So what is 7? 7 is 6 plus 1. Okay, I pass the higher value here. Okay, 7. But what is 3? 3 is going to the lower value here. So once I did the iteration with value higher plus 1, then I'm going to do iteration with value, okay, lower itself. Okay, see, you like to know that, but just see the iteration here. My idea of this is I just want you to understand the approach that is happening here. Okay, the how the 2-point approach is working. That's why I'm showing you this. Okay, next let us try with the value 3 now. Okay, so what is happening? This is my whole window. Okay, what is the sum of lowest plus highest? It is going to be 7. 7 is less than 3. No, remove the last element. Okay, this is the one, right? What is that? 0 plus 5 is 5. Is 5 less than 3? No, remove the last element. So what is that? It is this now. Okay, so 0 plus 4, it is 4. Is 4 less than 3? No, remove the last element. Okay, this thing is 4. 0 plus 4 is 4 less than 3? No, remove the last element. Okay, you are getting this. Yeah, 0 plus 1, 1. Is 1 less than 3? Yes, it is less than 3. So how many pairs we can form? We can form one pair. Okay, so we have one pair now in our answer. Okay, if you see it, there is one pair now. Okay, next what we have to do, remove the first element. Okay, after removing the first element, we are left with only one element. Okay, a pair cannot be formed with one element, so we'll stop there. So what we have, see the number of pairs, okay, with a value less than 7, that is with the sum less than 7 is 7. The number of pairs with the value that is sum less than 3 is 1. So can you quickly tell me with these two, can we get the answer? The answer is going to be 7 minus 1, which is 6. Okay, I will tell you how it works. See here, this particular function what you're seeing here, it will tell me number of pairs, okay, having a value, having some value less than this particular value. Okay, do you agree with me? Yeah. So how to find the answer now? See what I'm going to pass. I'm going to call this function for upper plus 1. Okay, what it will give me, see in the first example, what it will give me, it will what is upper plus 1? It is 7. It will give me number of pairs having a value, having a some value of less than 7. Why less than 7? Remember value itself is 6, right? So I want a, that's why I'm giving 7 in the input. Okay, if you see I'm doing upper plus 1, why? Because my upper itself starts with 6. So I want the pairs to have a value less than 7, that is from 6 onwards. Okay, so this particular value will give me that. Okay, what is the other thing? I want the pairs, okay, having a sum which is less than this particular value, which is less than 3. Okay, less than 3, remember, not including 3, it should be only less than 3. Okay, so I will get that number also. Then both the numbers I will subtract. Okay, if you see here I'm subtracting both the numbers. Okay, if you see here I'm subtracting both the numbers, and that is going to be my answer if you see here, correct? Okay, so yeah, that is what it is. See, what is the first value going to return? It is going to return number of pairs having sum less than 7. Okay, but what is, okay, let me quickly write it here. Okay, what is the first answer going to return? It is going to return a value which is having less than 7. Okay, having whose sum is less than 7. So what all the sum could be? It could be 6, it could be 5, it could be 4, it could be 3, it could be 2, it could be 1, it could be 0, and so on, right? And so on. What is the second thing going to return? It is going to return the number of pairs having a value less than lower. Okay, what is lower here? Lower is 3. So what could be the sum of those pairs? It could be 2, it could be 1, it could be 0, and so on. Okay, when I subtract them, what is going to be subtracted? These two parts are going to be subtracted. Okay, these two parts are going to be subtracted. So if I write a minus symbol here, can you quickly tell me what after subtraction what all will be remain? Only pairs whose value is going to be 6 or 5 or 4 or 3. Okay, so we are going to left with only the pairs whose sum is like this. Okay, so if you see here, this comes in this range. Okay, 3, 5, 4. Okay, sorry, 3, 4, 5, and 6. Okay, so only those pairs whose sum is this, that will be written, and that I'm going to return as my answer. So if I can quickly run this and show you, that is what is happening here. Okay, I have to comment out this part, otherwise it will work. Okay, let me quickly comment this out. So see, like why I'm explaining the solution, because see, I have already have multiple solutions. Okay, but the thing is, LeetCode, he is expecting only this kind of solutions here. Okay, any solution which having a logarithmic time complexity, other solution will not work here. Okay, that is the simple idea. That's why I'm explaining this solution. Okay, you can try it out other variations. I've also tried that out, but they are not working when you submit them. Okay, as simple as that. So yeah, so if you see the time complexity, see basically this particular function takes overfund time. Okay, it takes just overfund time because we are simply moving a window out of a year. Okay, we're starting from the extreme ends and then we're sorting the window, as simple as that, right? So this overfund time. So we are calling this function two times. This takes overfund time. This takes overfund time. Okay, and at last you see here we are doing sort. So sort again takes off and log n. So highest among them is going to be n log n time. Okay. Now coming to the space complexity, see we are not using anything as such here. Okay, but yeah, see the idea here is when you sort something, okay, some additional space will be required. Okay, temporary some additional space will be required. If you consider them, then the solution of this is going to be ofn. Okay, but ultimately, see, ideally you should not be considering this kind of complexities. Okay, if you are sorting, then those complexities are temporary and they are your whole program while the program ends, these things will not be written. Okay, this will only return while the sort is happening. After that, those values will be taken back. So ideally they should not be contributing for the space complexity, but still, depends on the interview that you're having. You can discuss with them. If they insist on adding those complexity also, you can add them. So in Python, the sort will basically take off and space complexity also. So you can add that. Okay, as simple as that. So this was the solution. When you segment this, you can just comment the printer outputs. The print outputs are only for your understanding. Okay, you can just comment that out. Now coming to the Java solution for the same. If you see the Java solution here, I am doing exactly same thing. Okay, there is nothing extra here. If you see in this case, but only thing is, yeah, previously inside. Okay, what happens in Python is you can declare a function inside a function, but here I am not doing that. Okay, here you will have to return this whole thing again. Okay, yeah. Just a second. I will hear this part. Yeah. So if you see here, basically, I'm creating another function here basically. Okay, because in Java you cannot have a function inside its function. Okay, as simple as that. So I'm declaring it with a private type, and the return type is going to be long. By long, if you see here, the answer is going to be long. So that's why here I also have declared as a long. So it's doing exactly same thing. Okay, it is taking count of pairs equal to 0. It is declaring the ends of the window. L and R. See, L is going to be the left end of the window. R is going to be the right end of the window. That is the basic idea. This function again does the same thing. It basically counts, okay, how many pairs are having a sum, okay, less than the value that is given as input to this. Okay, that is the basic idea. And I'm first sorting it. Okay, in Java, basically the sort takes a space of log n. Remember that Java, the after sorting, it takes a space of log n during the sorting. Okay, remember that. But yeah, the time complexity remains the same. It is n log n only. Remember that. Even in Java, this time complexity of the sort is still the same. Okay. So I'm doing exactly the same thing. Only the sorting, the way I'm doing it is different. And finally, I'm returning those values. Okay. I'm calling this particular function for upper plus one. Okay. And then I'm calling this function for lower. Okay. Remember, in Java, you'll have to pass the array also, because see, there are two ways to do it. Okay, either you can declare this array as a member to this particular class. Either you can do that, or you have to pass every time. Okay, that is the other way. So either way you can do that. Yeah, both way you can try and see which is taking less time when you're running the solution. I will insist that you take it as a data member and do it. That is also great. Okay, so I'm doing exactly the same thing. You see, I'm turning a window till L is less than R. Okay, then what we are checking, if the sum of the left, that is sum of highest value of the window and the lowest value of the window, if it is less than the current value, that is the value that is given to us, what you have to do, we are getting some pairs out of that. Okay, calculate those pairs. Those pairs are going to be R minus L. Okay, I've explained to you in the Python solution. Basically, I've explained to you in detail like how those values are coming. Okay, you have to add that. Fine. What I'm doing next, since remember one thing, since in this case it is the highest plus lowest is less than the value, what you have to do, you have to increase the left of the window, that is increase the smallest element here. Try to take a small, that is the idea here is the smallest element of the window can be slightly bigger, so we are just moving it forward. Okay, and taking slightly bigger value which has a smaller value. If this doesn't happen, that is the smallest and the highest value is exceeding the value or equal to value, what you have to do next, in that case we have to reduce the highest value in the window. Okay, that's what I'm doing. Okay, the right is equal to right minus 1. Okay, as simple as that. So I'm reducing the right, which is the highest value in the window. Okay, as simple as that. This whole loop will continue, and at last we are returning the count of pairs. This is going to be a long value. Okay, since it may cross the integer, the space allotted to integer, so we are taking a long here, as simple as that. At last, what we are doing this. Okay, first I'm passing this for upper plus 1, and then I'm passing this for lower. Okay, if you want to understand why I'm passing like this, let me show you this quickly. Okay, so let us say, see, in this case upper is 6, lower is 3, right? So when I'm passing it for 6, okay, I'm getting the count of pairs, okay, having some of this values. Okay, either the sum can be 6, or the sum can be 5, or sum can be 4, and so on, right? That is, it is giving me number of pairs with a sum less than 7. Okay, so these are the sums that those pairs could have, right? These are the ones. Then what I'm passing, then I'm calling this particular function for lower. What is lower here? 3. That is, it will return the count of pairs having a sum less than 3. So what all the sum could be in that case? 2, 1, 0, and any lower value in that. Okay, if I subtract both of these, okay, if I subtract both of these, what I'm going to get, I'm going to get pairs whose sum is going to be in this particular range. Okay, in this particular range. Okay, 6, 5, 4, and 3. And if you see in the question, that is what is needed here. Okay, the pairs whose length is going to be in this range. Okay, whose sum is going to be in this range, that we have to return. So yeah, and that was all for today. This question I felt was slightly tricky, though it looks simple, but still the kind of expectation that LeetCode has, okay, the kind of expectation they have set for the acceptance of this that was slightly high on the higher side, I felt. Okay. So yeah, fine, that was all for today. I've already explained you the space and time closure of both the solutions. For Java, the only difference is the space compatibility will log in instead of open. Why? The only thing is, if you see the sort part, it is claimed that the sort in Java takes O of login, okay, but in Python takes O of n. Okay, that is the only difference here. Other than that, everything remains the same. The time complexity remains the same in both the solutions. So, yeah, friend, that was all for today. If you like my words, please do subscribe to my channel. But see, originally I felt that this question did not have much for us to learn. Okay, at least I felt that. I tried multiple approaches so that I can show you something different, but those were not getting accepted. Okay, ultimately I realized that okay, they are not accepting those approaches at all. Okay, so because it is 10 power 5 range, so they are trying to have a n log n solution. Okay, anything other than that, that is not getting accepted. As simple as that. So I could not show you much, but yeah, at least you could learn the 2-point approach from this question. That is the only thing I can conclude this video with. If you like my efforts, please do subscribe to my channel. See you tomorrow. Thanks a lot.